All right, so today what we're going to do is take what we've done with our Taylor and Maclaurin polynomials, and we are going to turn it into a series. Now, that's really easy because all you have to do for a series is you have to add a plus dot dot dot. So notice that the formula is the same. Here is our basic term. It's the nth derivative at our center times x minus c to the n over n factorial. But notice we have this plus dot 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 and here, and then we have this plus dot 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 here, okay? So that turns it into a series by simply adding the plus dot dot dot. Also remember, we've talked about a Maclaurin. A Maclaurin series is always centered at 0. So if I say write the Maclaurin series, I don't have to tell you what the center is. And just to remember, a polynomial ends, so there is no plus dot dot dot. A series did not end. There needs to be a plus dot dot dot. It might show up with a sigma. It doesn't have to. And then it also has what we call a general term. Which is where if you remember from series before semester break, we were looking at all of these things with sigmas and we were trying to decide if they converged or if they diverged, and then we found interval of convergence. This is where we were leading to. So we're going to use our general term that we write to do the things that we did last semester. We're just writing it ourselves instead of starting with the general term given to you. All right, so let's practice again. We have got our first function is e to the 5x. So there is our function, and we're centered at 2. So remember, that's what goes in our derivative value. So we start with n equals 0. So we want f of x, which is e to the 5x. And so if we plug in 2, we end up with e to the 10th. Now when n equals 1, we want f prime of x. That means we would bring our 5 in front, and we would get 5e to the 5x. So when we plug in 2, we end up with 5e to the 10th. For n equals 2, we want f double prime of x, which would be 25e to the 5x. And when we plug in 2, that would give me 25e to the 10th. And then finally, for 3, we would want f triple prime of x. Bringing out another 5 makes it 125e to the 5x. Plugging in 2 makes it 125e to the 10th. All right, so we want the first 4 non-zero terms. That's typically what they're going to ask you to write. So if you show up with 0 anywhere in your list, then you got to go until you get 4 of them that are not 0. And we're not going to put a p because it's not a polynomial, it's a series. So we're going to start out with our formula. So it'd be e to the 10th times x minus 2 to the 0 power over 0 factorial. That's our first term. Then it would be plus 5e to the 10th times x minus 2 to the first power over 1 factorial. That's our second term. And then we have a plus 25e to the 10th times x minus 2 squared over 2 factorial. Third term, we need one more. So plus 125e to the 10th times x minus 2 cubed over 3 factorial. Now remember, this is a series, so what does it need to have on the end? Please tell me you said a plus dot dot dot. Okay, so that's what turns our polynomial into a series. So now we want to write an expression for our general term. So our general term is basically a formula to generate these terms. And when we're looking at our formula, we always start with n equals 0. So this would be n equals 0, this would be n equals 1, this would be n equals 2, this would be n equals 3. So it looks like we have an e to the 10th in every term, but we've got a coefficient that changes in front. In fact, that coefficient matches 5 to the n power, because that would be 5 to the first, that would be 5 squared, that would be 5 cubed. So it looks like our general term is going to have a 5 to the n times e to the 10th. Then we have our x minus 2, which looks like it matches to the n power. And then on the bottom, 0 factorial, 1 factorial, 2 factorial, 3 factorial, it matches our n factorial. So that is our general term. Now, typically, if you were writing this as all one thing, you would put another plus dot, 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 because it goes on forever. All right, for the next one, we have used the general term to find the interval of convergence. So we've got, here's our general term. It's non-geometric, so we are going to use our ratio test. So we want the limit as n goes to infinity. Now remember, our ratio test is a sub n plus 1 over a sub n. So we take our first term, our general term, and we put n plus 1 everywhere there is an n, so x minus 2 to the n plus 1 over n plus 1 factorial, and then we multiply it by the reciprocal of the original. So that would be n factorial over 5 to the n times e to the 10th times x minus 2 to the n. All right, now we need to simplify. Hopefully you remember how to do this from last term. E to the 10th cancels out completely. Remember, your largest factorial stays but loses its factorial. The x minus 2 to the n plus 1 cancels out that, and we're left with just, let's see, I'm going to circle them as I'm left. So I've got an x minus 2 left, I have an n plus 1 left, and then my 5s, I'm left with just a 5. So we're looking at the limit as n goes to infinity. What do we have left? A 5 and an x minus 2 over an n plus 1. Now, we're looking at that goes to infinity, so be careful. What's our variable here? We have an x and we have an n. Think about it for a second and tell me what your variable is. Hopefully you said your variable was n. So if your variable is n, and we're looking at this in terms of top heavy, bottom heavy equal, my function or my expression is bottom heavy, and when we're bottom heavy, our limit is 0. So remember with the ratio test, it says that if the limit is less than 1, then it converges. So then this means, when we get 0, remember, that means that it doesn't matter what x value we pick, it will always be 0. The limit will always be 0, which is less than 1. So remember this was opposite when we did our interval of convergence. So when we got 0 as an answer, it meant our interval of convergence was everything. Negative infinity, less than x, less than infinity. Remember, and our radius was equal to infinity. I don't know if you remember that, but remember they were in opposition. You ended up with 0 as a limit, and you could take everything for x. So that is the interval of convergence. So what does that mean? Think about it for a second. What do you think that means? Okay, what that means is that it doesn't matter what x value I pick. I can use this polynomial for any x value I want, and I will get a good approximation to plugging in the function e to the 5x. And that's actually what a lot of computing systems like calculators, computers, they don't use e, the number 2.71, la, 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 la. They use a series, or actually they'll do a polynomial so that it ends, but they'll use 100 terms or 1,000,000 terms, and they'll get an approximation value that is so close to the actual value that there's no distinguishing. And for this polynomial, we're saying that you can do that for any x value out there. So I know we're centered at 2, but I could go as far away from 2 as I wanted to, plug it into my polynomial, and I would get a good value for e to the 5x. Hope that makes sense. All right, let's see what the next one is. Hopefully you're seeing how it all ties together. All right, so now we've got our Maclaurin series, so we know we're centered at 0, and our function is cosine of x. So for 0, we want f of x, which is cosine of x, and cosine of 0 is 1. For n equals 1, we want f prime of x, which is negative sine of x. Well, negative sine of 0, remember we're not plugging in n. This is one of the mistakes. We're not plugging in n. we're plugging in our center value here. So we're plugging in 0. Sine of 0 is 0. So what that means is that that term doesn't count. Okay, so when we go to list our first 4 non-zero terms, that one doesn't count, which is why the table is so much bigger than the others have been. So when we go to 2, we want f double prime of x, so that would be a negative cosine of x, so that would be -1, again, plugging in 0. For n equals 3, we want f triple prime of x, which would be a positive sine of x. Darn, that's back to being 0. For 4, we want f to the 4th of x, which would be a positive cosine of x. At 0, that would be 1. So I've got 1, 2, 3 so far. At 5, it would be the 5th derivative of x, which would be back to negative sine x, which at 0 is 0. And so hopefully this will do it for us. At 6, we want the 6th derivative of x, which is negative cosine of x, which puts us at -1. So that means we got 1, 2, 3, 4 numbers that we can work with. All right, so our first 4 non-zero terms. So starting out at 1, our n was 0, so it's going to be 1 times x minus 0 to the 0 power over 0 factorial, plus, now we're at 2, so it's going to be a -1 times x minus 0 squared over 2 factorial, plus, now we're at n equals 4, so it's going to be 1 times x minus 0 to the 4th over 4 factorial, plus, now we're at n equals 6, so it's going to be -1 times x minus 0 to the 6th over 6 factorial, and then remember, it needs to have a plus ... Okay, when we go to write our general term, this, you just go with me, okay? This is the way it has to be. When we write our general term, when we're looking at series, our n value cannot skip. Okay, so when we have missing terms like this, we have to relabel. Once we've written our series, we have to relabel our n values. So this is n equals 0, this is n equals 1, this is n equals 2, and this is n equals 3. Because when you're talking about a series, remember, with a sigma, our n is our variable, and our n cannot skip. It's every integer. We can't tell it to skip an integer when you're plugging things in. So we've got to go back to renumbering in consecutive instances. So our general term, well, it looks like we've got a +1, a -1, a +1, a -1. So that's an alternating piece. So that's going to be a -1. Now, when n is even at 0 and 2, our power is positive. When n is odd at 1 and 3, our derivative is negative. So we want that to just be n. Now we've got our x minus 0, and you could write it just x if you want to. That's to the n power because it runs right along. Nope, it's not to the n power. How do we go from 1 to 2, 2 to 4, 3 to 6? That's 2n. Okay, there we go. Over, now the same thing applies as with our exponent as it does to our factorial. So we're going from 1 to 2 factorial, 2 to 4 factorial, 3 to 6 factorial. So that would be 2n factorial. You got to make sure you put it in parentheses. And then we put a plus ... All right, so that's our general term for the Maclaurin series for cosine. So now let's find the interval of convergence. So we're going to do, it's not geometric, so we're going to have to use the ratio test. So the limit as n goes to infinity, absolute value. Guys, please, it is absolute value. Absolute value means that you can ignore the alternating piece. Don't keep it in there because that messes up y'all's answer. So we have this x minus 0. Now, when I plug in n plus 1, it's 2, and then in parentheses, it's n plus 1, over 2, and then in parentheses, n plus 1 factorial, times 2 to the n factorial over x minus 0 to the 2n. Now, I'm going to simplify these two pieces first before I simplify the expression. So I'm going to have the limit as n goes to infinity. So that would be x minus 0 to the 2n plus 2 as I distribute the 2. And on the bottom, I'm going to have 2n plus 2 factorial. Now this one I'm going to keep the same. So 2n factorial over x minus 0 to the 2n. Okay, so now let's go try and cancel. Well, the x minus zeros will cancel, but notice I've got 2n plus 2 and I've got 2n. So if you subtract that, this guy goes away, but it leaves me with a squared on the top. It leaves me with 2 of them extra on the top. Now, 2n factorial. This one is going to be a little bit different because we're going to start out with 2n plus 2. Then we would subtract 1 and we would get 2n plus 1. Then we would get to 2n factorial. So those go away and I'm left with both of these guys on the bottom. All right, simplifying or rewriting it in its simplified form would give me x minus 0 squared over 2n plus 2 times 2n plus 1. Same thing as last time. Remember, n is our variable, so this one is bottom heavy, so the limit is equal to 0 regardless of the x value that I choose. So that means my interval of convergence is going to be negative infinity less than x less than infinity, and my radius is infinity. So again, that means that this Maclaurin polynomial will give us a good approximation for cosine of x for any x value out there, no matter how far away from 0 we get. All right, let's see what our next one is. All right, last one is natural log of x. And we're centered at x equals 1. Here's our function. So for n equals 0, we want f of x, which is natural log of x. Natural log, remember that goes there. Natural log of 1 is 0. So that does not work as one of our terms. For n equals 1, we want f prime of x, which is going to be 1 over x. Plugging in 1, that gives me 1. That's our first term that's going to count. So for n equals 2, we want f double prime of x, which is going, remember this is x to the negative 1, which is going to be negative 1, x to the negative 2. Well, this is always going to be 1, so we just leave us with the negative 1. Two terms, need another one. So f triple prime of x, bringing that negative 2 in front, would give us 2x to the negative 3. Plugging in 1 would give us 2. And we need one more, so the fourth derivative of x is equal to negative 6. X to the negative 4. Plugging in 1 gives us negative 6. Okay, so we don't have to write that one. So we start with this one. So it would be 1 times x minus, 1, not 0, x minus 1 to the first power over 1 factorial. Remember, we skipped the 1 with the 0. You could write it if you want to, but I skipped it. It doesn't count. So my first one is to the first power. Then my next one, plus minus 1 times x minus 1, we're at squared over 2 factorial, plus 2 times x minus 1 cubed over 3 factorial, plus negative 6 times x minus 1, so what am I, to the fourth over 4 factorial, and of course don't forget your plus dot dot dot. Now, on this one, if we start with n equals 0, all right, if we start with n equals 0, let's do the easy part first. I've got x minus 1 to the first when we have n equals 0. We got to turn 1 to 2, 2 to 3, 3 to 4. So that means we're going to have an x minus 1 to the n plus 1 power. On the bottom, same thing. We've got 0 to 1 factorial, 1 to 2 factorial, 2 to 3 factorial, 3 to 4 factorial. So that would be an n plus 1 factorial. Now let's talk about our derivative values. We have a 1, a -1, a 2, and a -6. So they alternate in sign, so we need a -1. Now, at the even powers, our number is positive. That's good. At the odd powers, at the odd values of n, our number is negative. So we just want it to be to the n. We don't have to adjust. Let's talk about the numbers themselves. 1, 1, 2, 6. Did anybody recognize that pattern? Remember, I told you you needed to remember that pattern. That's the pattern of factorials. So 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6. So this is actually n factorial up here. Now before we go do and then we need a plus ... And before we go do our interval of convergence, I want to simplify what we have right now. So notice this n factorial and this n plus 1 factorial. Just like when we're doing the ratio test, I can simplify those like that. I can take out the n factorial on top, and I can remove the factorial on the n plus 1. So my new general term becomes -1 to the n times x minus 1 to the n plus 1 over n plus 1. Okay, so that is my general term, and that's simplified a little, so that makes it better. All right, so now let's do our interval of convergence, or our ratio test. So we have the limit as n goes to infinity of the absolute value. Again, it's absolute value, ignore the -1 to the n. So we start with x minus 1 to the n plus 2, because it would be n plus 1 plus 1, over n plus 2 times, flip the original, n plus 1 over x minus 1 to the n plus 1. Okay, simplify what we can. Remember, you cannot simplify the polynomials, so I am going to go ahead and circle those. On my x minus 1s, the one on the bottom disappears, and I'm left with 1 on top. So if I go to rewrite this, I have the limit as n goes to infinity of the absolute value of x minus 1 times n plus 1 over n plus 2. This time, with n being my variable, I am equal. So remember, it's the ratio of the coefficients. So that's going to be the absolute value of x minus 1, and we need that less than 1. Y'all just looking familiar to you? All right. So now we're going to do our absolute value inequality. So we've got -1 less than x minus 1 less than 1. If we add 1 to both sides, that would be 0 less than x less than 2. Now, remember, at 0, my ratio ends up being 1, or my limit ends up being 1, and at 2, my limit ends up being 1. So that means we have to go check those points, because the ratio test doesn't tell us anything when our limit ends up being 1. So at x equals 0, we're going to come back up here to the general term, and I'm going to plug in 0 right here. So this would be -1 to the n times -1 to the n plus 1 over n plus 1. Okay, we need to simplify this. So since they're same bases, I can add the exponents. So that would be -1 to the 2n plus 1 over n plus 1. Now, is this really alternating? We've got to check. When I plug in 0, I get 1, and it's negative. When I plug in 1, I get 3, so it's negative. When I plug in 2, I get 5, so it's negative. When I plug in 3, I get 7, so it's negative. So no, this is not really alternating. This is really the series -1 over n plus 1. So we need to determine if that series converges. Well, I am going to do, let's see, I will do limit comparison, and I'm going to compare to -1 over n, and we know that diverges by p-series. So we're going to do the limit as n goes to infinity of negative 1 over n plus 1 divided by negative 1 over n, which is the limit as n goes to infinity of n over n plus 1, which is equal to 1. They're equal. Remember, limit comparison says as long as I get a positive number here, then they both match. So therefore, we diverge at x equals 0. Let's see what other color I can come up with. How about a pink? Okay, so now let's do at x equals 2. So plugging back into our general term, we have negative 1 to the n times positive 1 to the n plus 1 this time over n plus 1. Okay, positive 1 to the n plus 1 we can really get rid of, so that simplifies to negative 1 to the n over n plus 1. Now, that is alternating. N is going to go from even to odd depending on what our n value is, so it's going to alternate in sign. So we're going to use the alternating series test. So the alternating series test says, remember, the limit as n goes to infinity of 1 over n plus 1 has to equal 0, which it does, and they have to decrease. So 1 over n plus 2 has to be less than 1 over n plus 1, which it is. So therefore, it converges at x equals 2. So my final answer for my IOC is going to be no to 0, yes to 2. So it's going to be 0 less than x less than or equal to 2. Notice that the center of my interval is 1, which is my center here, and my radius is going to be 1. So you thought, well, you got away from interval of convergence and those pesky 8 convergence divergence tests for series. Of course not. We're going to keep working on them. All right, if you have any questions, come see me, guys. Bye-bye.